All right, we're going to do example A together right now, and they want you to just write an equation for each graph. So you're given the graph, and you have to come up with an equation for it. Great. We could do that. So let's talk about A. What do you see with that red line up there? What kind of line is it? A straight line. All lines are straight. Linear. All lines are linear. There's an H word. It's a horizontal line, right? That comes from a constant function. And the constant function comes from the two things canceling, and you're being left with just a number. So in other words, things are going to cancel here. Here's what I want you to do to make a graph. If you see a hole in the graph, do you? Okay. Make a fraction. At what x value is the hole? 2. So the bottom's going to have an x minus 2 in it. Do you remember when we found roots or intercepts? We would do x minus r1 and x minus r2 and all that. Kind of the same thing. Kind of like 2 is an intercept, but it's not. It's called a hole in the graph. So it's going to have x minus 2 in the bottom. But since it created a hole, there must have been also an x minus 2 where? Up top. For there to be a hole in the graph, that factor that caused the problem down there must have had a partner up top to cancel with. All right? So this function definitely has an x minus 2 on top and bottom. Last thing. How far up is the horizontal line? It's up 3. Wherever that line is, wherever that number is, put that number on top with the x minus 2. If you graph 3 times x minus 2 over x minus 2, you should see ready? So go ahead. We're going to do 3 times x minus 2 over the quantity x minus 2. We want it to be a flat line with a hole in it. Flat line with a hole in it. Where? Give me the coordinates. 2, 3. Trace 2. Enter. You should see nothing. Why nothing? That's where the hole is. What are you going to see for y when I click right 1? No. It's always at 3. But where's the hole? At 2, 3. There's a hole. We successfully made the equation that produced that graph. Let's move over to B. Are you ready? Does B have any holes in it? Let's look closely up here. Does B have any holes in it? I don't think so. Does B have any asymptotes in it? 2 of them. Okay? So it has 2 factors on the bottom that don't cancel with anything up top. All right? 2 things on the bottom that don't cancel with anything on top. Where are they? Where are the asymptotes? One's here. 1 and negative 2. So on the bottom, hold on, I'm getting there. Just talking vertical asymptotes. Good question. The question was, isn't the x-axis an asymptote? We're getting to that. All right? So the bottom is going to have what? I need 2 places where there's going to be a problem down there, but there's nothing on the top to match to cancel it. X plus 2, x minus 1 is correct. The x minus 1 is guaranteed to be on the bottom because where's this asymptote? 1. So there must be an x minus 1 on the bottom. Where's this asymptote? Negative 2. So there's got to be an x plus 2 on the bottom. Those are the two x values that would cause the bottom to become 0. All right? So at this point, we're trying to figure out what goes in the top of this function. All right? What goes in the numerator? I know it's not just a number, because if it was just a number, would there be an x-intercept? Listen to that closely. If I had a number up here like 8, would this graph ever cross the x-axis? No. Does this graph cross the x-axis? Where? At negative 1. So listen closely. So negative 1 is a blank of this function. A 0, good. That's another name for that. X-intercept, right? Or a root. If negative 1 is the x-intercept of this function, I think there's an x plus 1 on top. Nice. I want everybody to think about that. If x plus 1 is on the top, what do you get when you plug in negative 1? 0. That's good, because it goes through negative 1, comma 0. There's an x plus 1 on the top. When it has that middle mysterious piece, the top's never just a number. It's got to have an x somehow. All right? And finally, everybody's favorite letter, A. Has this weird rational function been dilated at all? We'll find out. We'll find out. It might not. It might. Let's go ahead and put an A there. Do they give you a point to work with? Okay. Go ahead and plug in 0. What's 0 plus 1? 1. What's 0 plus 2? 2. What's 0 minus 1? And what's negative 1 times 2? Negative 2. So there's no A. A must be 1. It hasn't been dilated. Without the need for a dilation constant, it goes through the point it's supposed to go through. All right? This is the function. Go ahead and check it on your calculator to make sure it looks like that.